Welcome to Brain Vision.
Our question says that how big is a ton? That is, what is the volume of something that weighs a ton? To be specific, estimate the diameter of a 1-ton rock. But first, just make a wild guess. Will it be a foot across, 3 feet across, or the size of a car? Rock has mass per volume about 3 times that of water, which is 1 kilogram per liter, 10 to the third centimeters cubed, or 62 pounds per cubic foot. So I wrote down what we were given in this problem. We were given that the density of water, which is mass per volume, that's density. So I wrote density as rho. So the density of water, which is rho sub W, is equal to 62 pounds per cubic foot. And it says that the density of rock, which I wrote as rho sub R, is 3 times the density of water. So 3 times rho sub W is 186 pounds per cubic foot. It also tells us the mass of the rock in question. And the mass of the rock is 1 ton. Well, by definition, 1 ton is 2,000 pounds. The question then is, what is the diameter of this rock if we assume that it's a perfect sphere? So the diameter, which I wrote as D, is equal to what? In order to do this, we're going to make use of the fact that the volume of the sphere is equal to 4/3 pi r to the third. 4/3 pi r. Oop, I forgot pi. Let's write. Well, I guess, yeah, let's write pi first to keep it consistent with what I said. In common notation, pi r to the third. Okay. Well, we can rearrange this to solve for r because we want r, since really what we want is distance, or the diameter, but diameter is 2 times the radius. So solving for the radius will be just fine. And the radius then is 3 times the volume divided by 4 pi. But the radius was cubed, so this entire thing is going to be to the cube root, or to the 1/3. Okay, well, all we need then is volume. And we can get volume using the fact that we know the density of the object in question and we know the mass of the object in question, because volume is also equal to the density of the object in question, or I'm sorry, the mass of the object in question, which is the rock, so m sub r, divided by the density of the object in question. And you can check real quick with just using dimensional analysis. So the mass is in pounds, and the density is in pounds per cubic foot. The pounds is going to cancel. All you're going to be left with is cubic foot, and volumes is in cubic foot. So we know the dimensions work out. So let's go ahead and carry out this operation. We have 2,000 pounds. Excuse me, 2,000 pounds divided by the density, which is 186 pounds per cubic foot. And if you do that, that comes out to be 10.8 cubic feet. Okay, so now we know the volume in question of the rock. So we can solve for the distance, or the diameter, the diameter. Diameter is 2 times r. Okay, so this is going to be 2 times equals 2 times 3 multiplied by 10.8 cubic feet divided by 4 pi. And all of that is raised to the 1/3. And again, the dimensions check out because we have cubic feet here inside the parentheses. Raised to the 1/3, you're going to be left with just feet, and you expect the diameter to be in feet, so it works out. If you carry out this operation, you find this is equal to 2.74 feet. And it asks us in the beginning if we thought it would be approximately 1 foot, 3 foot, or the size of the car. Well, 2.74 feet is approximately 3 feet. So there's your answer. Go ahead and box that in.